Hello. Uh, good. Okay. Good morning. So today's workshop is going to be the development environments. So welcome and let's get started. So the workshop's going to cover what a development environment looks like. And development environments are just like the platforms and tools that coders such as yourselves will be working with to accomplish your goals. So let's get started with who I am. Quick intro, my name's Adele. I've been part of nwPlus for about 1 year now. I'm on the external dev team, which means I work on the website for like HackCamp and the nwHacks website, which is coming up. And I'm a current 4th year in statistics at UBC. So let's get started with the learning objectives. We're going to be covering the very basics of what coding might look like, and then kind of talk about how an IDE might come into play. I'm going to talk about what an IDE is pretty soon. So the learning objectives are things like the code lifecycle, the intro to the IDEs, and just some cool features. Before we get started, I wanted to start off with something that might be a lot more familiar with people who have taken CompSci 110. And even if you haven't taken CompSci 110, it's okay. This is just an example. So when you do CompSci 110, you have to code in something called Dr. Racket. And as you guys, if you are familiar with it, it's as simple as you write your code on this first little column over here. You see outputs on the column over here. And then you are able to write every code that you write, you can run just by clicking this button over here. You're able to stop your code at different parts of it and step through it using the macro stepper. So I'm going to be talking about what all of these components do. And if you're already familiar with it, this whole workshop will really make sense to you. So let's start off with the code lifecycle. So one of the first things you do when you start coding is writing code. And coding is just the process of using a programming language to get a computer to behave how you want it to. So a really important part of it is the process of writing code. Usually writing code is done in an editor. A really basic example is the Notepad app. But if you look at the Notepad app, it's really not that informative. Especially when you're writing small lines of code, it makes sense. You have like a variable, say text equal to hello world, and you print the text. And that's pretty simple. It's really easy to read. But you can easily imagine that once you have like maybe hundreds of lines of code or different files and all that, it's really hard to read through the Notepad because it doesn't have one of the most basic things, that's syntax highlighting. Syntax highlighting is just adding simple visual cues in your text, such as colors or different fonts, and it makes it really easy to be able to read the code that you write. And the other issue that I mentioned is, imagine if you have multiple files, because when you're writing code especially, you won't have one single file. When you're writing big programs, you have multiple files working together. So you're writing code in different files, and that's mostly for organization purposes. And it'd be really cool if like Notepad had something where you could see a whole folder hierarchy or all the different files, and just gives you a better understanding of the entire project that you're working on. So compilation. So if we think about a programming language is just a formal language comprising of a set of instructions, and it gives you an output. The programming languages we usually write are in very high-level languages. And these are usually abstracted to keep it simple for us as humans to read and understand. But computers, on the other hand, they understand bits and bytes and like zeros and ones and like really low-level languages. So how does a computer understand all the code we write in like high-level languages such as C, Python, Java? That's the role of a compiler. A compiler's job is to compile the high-level languages into low-level languages and then feed it to the computer so the computer understands. And that kind of brings up this question. So, well, when you think about it, if we have different languages, does that mean that there's different compilers? The answer is yes, because not every computer will understand different languages unless there's a proper compiler that converts the code. And compilers also have this cool thing where it tells you if something goes wrong. Their other job is to look at the code. If there's something missing in the code that it comes off as an error, it's called a compilation error. Debugging. Another really important part of the IDE process or like the development environment is debugging. And debugging is just being able to test your code, being able to find and reduce errors. And usually it's done through like really good debugging tools. And a lot of modern IDEs have debugging tools in them. And debugging tools are just computer programs that basically let you test the code. They also have a really cool feature of letting you stop at certain parts of your code as you're executing your code. And then you can like stop at that process, and then you can inspect different variable values and look at different aspects of it just to see if everything's working well. So let's put it all together. Basically, the three things that I talked about, the writing code, debugging, and the compilation, those all make up the basics of what is called a development environment. And so a development environment, a formal definition for that is just that it's a collection of tools and procedures for developing, testing, and debugging an application. So now that we think about that, wouldn't it be really cool if we had something that combined everything and we need it for development? And that's where an IDE comes. An IDE stands for Integrated Development Environment. And normally it just contains source code editors, some build automation thing, and a debugger. And it really depends on what you want to build. You will use an IDE for that purpose. An example is if you want to make applications for Apple devices, such as iOS, you want to use Xcode. And if you want to do something very Java related, they have specific IDEs for that. And I'll get to that in a bit. Okay, but before we continue, I want you guys to go ahead and collect your stamps from the text channel for this workshop. Okay, I'll give you guys 1 more minute just to collect your stamps, and then we can get started. Okay, I'll continue. So this brings the previous question, which is how come certain IDEs support certain languages? Initially, when people started making IDEs, it's mostly started by bigger companies, or it started off as open source projects. And open source projects are just projects that multiple people work on their own time, and then you can see the entire code. And the reason they did that was because they wanted to address a very specific need in the software industry. Sometimes you're making very high-level commercial applications, let's say in Java, and you needed an IDE that could address like very specific needs in that ecosystem. And so big companies, commercial companies, or just there or a lot of development of just open source projects that let that happen. An example of this IDE is Xcode. Xcode was an IDE developed by Apple because when Apple was released, they had their own language for writing their own software. So they wanted to provide an IDE that fit their experience for their developers, and work really well with their ecosystem. And recently, there's a lot other IDEs, such as Visual Studio Code, and these are very extensible. They support a lot of different programming languages, and that's what we're going to be working for this workshop. So let's start off by looking at Visual Studio Code. Visual Studio Code is a free source code editor, and it's an open source project made by Microsoft for Windows, Linux, and Mac OS. You can really easily just Google it and you'll be able to download it. It is also in the pre-workshop work list, so I hope you guys had a chance to go over that and download it. And the idea is that it provides just the tools a developer needs for a quick build, debug, cycle, and leaves a little more complex workflows to a more fully fleshed out IDE, such as Visual Studio. Um, by that basically means that you're able to do some very basic coding, but if you wanted some really heavy duty IDE, usually go for a more commercial IDE. So I have this slide up in case you guys didn't have a chance to go through the pre-workshop checklist. I will give you guys 2 minutes just to go through it and download Visual Studio Code. It's really simple. Just go to Google and search for Visual Studio Code, and you'll be able to download it real quick. So I'll give you just 2 minutes. Also, while you're at it, I strongly encourage looking through their documentation. They have a lot of really good docs, and it's really important as a developer that you learn how to read through documentation and like learn about what you want to learn more about. And it's really well documented. And if you want to learn a specific language or you want to know how to set it up for a specific language, they have it a really good documentation. I think the links in the second link, code.visualstudio.com/docs/setup/setup overview. And for languages, they have /languages/overview. So strongly encourage going through them if you wanted to code in a very specific language. Okay. Hope you guys had a chance to go through it. I'm going to quickly do it with you guys for those who haven't. It's really simple. Just this is the VS Studio Code website. Yep, you can just hit download. It'll detect your OS and let you download it right away. And yeah, we can get back to it. Oops. Sorry, just. Huh. Sorry, just I'm having some technical issues. Give me 1 second. All right, sorry about that. We are back. I was just having some technical issues. Okay. All right. So the first thing about VS Code and why it's really good is that it's really easy to add new functionalities and support for different languages through things like extensions. In VS Code, you can easily get new extensions through the IDE. They have a extensions marketplace where you can easily just go in there, search for anything you want. So if you want to code in, let's say, Python or Vue, and if you needed something that would automatically add syntax highlighting for that, you can just search through it. They have linters, they have prettifiers, they have everything you need. And I'll get more into what they are. So syntax highlighting. So with VS Code, you see right away that there's a lot of visual cues. And if we compare that to the Notepad application we're looking at, this has coloring. So like all the programming commands or like command logic such as if statements, endif, and macro, they all are colored in purple. You can see that strings are purpled in this orangish color, and it's just in general a lot more easier to read. And so that's one of the biggest perks of having an IDE with like syntax highlighting and all that. Code completion. So this is really useful to speed up and save time by auto-completing a lot of the code you need. A lot of more modern IDEs have support for code completions, and it's usually things like when you're searching for variable names, or if you're trying to find a method, it automatically detects what you kind of want to do and gives you a bunch of suggestions on what you can do. And this is really cool because you don't have to constantly go and read the documentation. You can just it just tells you what it is. And some IDEs also have a mini snippet of a documentation of what a function does. So in case you ever get stuck or you're trying to figure out what to do, you can just read it right through the documentation. And lastly, better project structure. So the other issue I talked about what Notepad was lacking was not having the project structure. On the left, I believe this is from IntelliJ, and on the right, this is Visual Studio Code. You can easily see the proper hierarchy of your folders and all the files, and this just gives you a better understanding of what your whole overall application is doing. Searching. Depending on the IDE you use, you get a lot of different features. This is really cool because a lot of the times, especially when you have different files and you have functions defined at certain places, you can just click a function name and just hit go to definition. And this just takes you to where you wrote that function or wherever someone else wrote that function. And this is really cool because, well, it saves you a lot of time. You don't have to constantly figure out what that specific function does and have to look around for that. Yeah, in general, saves you a lot of time. Refactoring, another very important aspect of IDEs, and this depends on the IDE you use, is that they have the ability to refactor things. So imagine you have a function like add two numbers, and you use it in like 50 places throughout your code. But then if you're changing the name to like add three numbers and you change some functionality in that, it's really manual work where you have to go through all 50 instances of where you used it and change it. But with refactoring support in IDEs, it's really as easy as just right-clicking and doing whatever the workflow the IDE has to refactor it. And then if you change the name, it changes the name for all 50 instances. So you don't have to like spend all that time. And yeah, refactoring is intended to improve the design, structure, and/or implementation of the software, and while preserving its functionality as well. So one of the main important reasons why we want to use an IDE is to increase our efficiency. And we have things like prettifiers, Git integration, and there's a lot of other cool features like live coding. So prettifier. Let's look at the two photos over here. The first photo is what would happen if you didn't have a prettifier. The second is what your code would look like if it had a prettifier. And why I'm showing you this is because a lot of the time when you're writing code, you're not going to be the only one working on that code base. You're going to have a team, and you're going to have other people writing code. You're going to have people who work before you. You're going to have people who are going to work after you. So a lot of times where you wanted to maintain some sort of consistency so the code is more scalable. Especially with multiple developers. And as your code base gets bigger, it's really easy if you have a prettifier, which will automatically change your code after you write it so it has a consistent format. This lets your code base scale a lot better. Git integrations. So I'm not going to be covering what Git is. I'm pretty sure there's another workshop pretty soon which will cover it. But basically, it allows you to collaborate with multiple people who are working on this code base at the same time and continuously make changes. Git is a type of a version control software. And that basically means it keeps track of the people who are working on the changes and apply the changes. And in Git, you typically work on your own branch. And usually when you're working with Git and if you don't have IDE support, you're usually working in terminal or PowerShell, and it's usually just hard to understand using everything using Git commands. And a lot of a cool thing about IDE is that they come with Git integrations. So it's things like visualizations, which make it really easy to reject or accept incoming changes. So an example is this image. If you look at that, you have incoming changes coming in from someone else's updates to your changes, and you can easily just see what they are, and you can just accept or decline. And if you did that on like terminal or PowerShell, that might be a little daunting. So that's really cool. And they also have things that let you see what the resolve merge conflicts. That's when you have changes to a specific part of the code that someone else made changes in. And it's really hard if you don't have an IDE which tells you what their changes are and your changes are and let you accept one or the other. So live coding. This is pretty self-explanatory. It's literally in the name. Imagine Google Docs for coding. So yeah, it's just like Google Docs. If you're writing code and you want to work with someone, it lets you share your code. It really depends on the IDE you use. Some IDEs have that built in. I believe in VS Code, it's an extension that you have to download. So yeah, and also, another cool thing about live coding is that it's not just coding, it's also the debugging step. So if you're planning on running a debug cycle and you want someone else's help, especially now that we're all working remotely, you can easily share your screen. And as soon as you run the debugger, the other person can see the debugger run as well. And if you stop in certain breakpoints, they see that as well. And also, like I said, it depends on the IDE you use because not all IDEs support that. Okay, so now I want to start the Python demo, but before I start it up, I'm going to give you guys some time to go to the link over here, code.visualstudio.com/doc/python/python tutorial, just so you guys can set up your Python environment. This was also part of the pre-workshop checklist, but I'll just give you 2 minutes in case you didn't have a chance to go through it. All right, I'm gonna quickly go over it with you guys. So, yep, if you follow the link, it's code.visualstudio.com/doc/python/python tutorial. This is what it looks like, and yeah, just go through all of this. If you don't have Python installed, you'd have to install Python, but in most Mac OSs, it comes with Python too, so you don't have to worry about that if you're using a Mac. Also, setting up the Visual Studio Code and the Python extension through VS Code. I'll go over it briefly on VS Code as well in case you guys are stuck. Yep, and this documentation talks about all Windows, Mac, and Linux in case you have problems. There's a lot of really good instructions over here. And you don't have to actually follow through the rest of the tutorial. I think if you guys set it up, that should be good enough. Okay. So this is what VS Code should look like when you open it up. This is what it looks like for me. I don't know if it's what you see the first time you open it, but yeah, if you open it, you'll see the left side where you can create a new folder or open any recent folders that you've had. On the right side, you can customize things, and this is really nice in VS Code because it links you to all the documentation that you might need if you wanted to add a certain color scheme, if you wanted to know how you can add support for certain languages and all that. And even cooler things like Vim, if you wanted to add key bindings and install settings for different keyboard shortcuts. So in our case, I wanted to start off with the extensions marketplace. So that's on the left side, this little bar on the left. And you can search for anything you need. For this case, I think it was Python. So that's where you'd go and you'd get the linter for Python. It gives you like debugging and all that. Another thing we are going to need for this extension, for this workshop is the Code Runner extension. So search up Code Runner. And Code Runner just lets you run code because if you guys remember, in Dr. Racket, you have the ability to run code. I don't believe VS Code comes natively with being able to run things. So this Code Runner extension is really handy if you want to run all code for all of these languages. So yeah, Python is what we're going to be using for this demo. But yeah, it will support every single one of these languages. And yeah, you should be able to install that. I don't have the button to install because it's already installed. And once you have that, it should just look like this. You should have this little button on the top right where it says run code. Yeah. Right. So once you guys have that set up, what you guys want to do is open a new file. And we want to save the file right away because that gives you linter support for whatever language you're coding in. So in my case, I am going to hit save as, and I am going into, oops, wrong folder. I'm just going to go into my desktop. Okay. I'm going to call it add. And if you want to code in a specific language, let's say Python, I usually just typically go to all files and change the extension. So .py stands for Python. So as you can see right away, like next to the add.py file name, you have like the Python logo. So that's how you know you already have support for Python. You usually get some, you might have, yeah. So like if you read on the bottom right, it tells you that it has the Python interpreter ready and all that. So it might even have a little pop up if you don't have Python installed properly, and it auto suggests you what to install from the marketplace. Okay, so for this example, I'm going to be doing something very simple, and that's just like a function just to add. And Python is just definition, and that's how you define a function. Don't worry if you guys don't know Python. This isn't the main workshop, but it's just to give you an example of how to use VS Code. So you guys can just follow along. And I'm going to call it add to nums. And you can add the parameters, x, comma, oh, all right. Interesting. Okay. I don't know. Okay, x comma y. Okay. And we want to return x plus y. And in this example, we're just going to see what it prints out. So we want to call add two numbers. And as you guys saw, that was an example of code completion where I didn't have to write the code myself. Okay, I'm going to zoom in a little bit more. How do I zoom in? Okay. I actually don't know how to zoom in. Appearance. Okay, I hope you guys can see that better. Hopefully that helps. Okay. And so if you call print add two numbers and you just pass in the two parameters, 1, 2. So we expect that to print out 3, right? So in VS Code, you just have to save it. So make sure you always save your file. So we're just going to save and then run the code. So when you run the code, you should be able to see the output. So if you remember Dr. Racket, we had an output panel, and in this case, it's right here. So that's super cool. And what I wanted to show you guys next was being able to debug. And if you want to debug, usually it's to the left of the line numbers. So let's say we want to stop at return x plus y, just to see what like the x value is and the y value that's being passed into it. So if you see the line numbers to its left, there's like a red dot. And if you click on that, that enables debugger. And you can debug by going to the debug section on the top and hit start debugging. And it's going to ask you what you want to debug. In our case, it's the Python file that we're currently on. So set that. We want to debug with Python. And okay, so what the debugger did is that it tried to run the command just like the run command, but it would stop at the breakpoint. So what I was talking about earlier is being able to set breakpoints so you can stop in certain parts of the code. As you can see, we can see what the x value is. We can see what the y value is. In the debug terminal, you can see all your breakpoints. If you have more than one breakpoints, you have a call stack. This comes really handy when you're debugging and you have functions that's calling other functions, and then you want to know which function called led to whatever line of code that you're currently on. So this is really helpful when you're debugging, and this is just a basic example of what debugging would look like, especially when you're working with like bigger code bases. Obviously, it's going to get a lot more complicated, and so I hope this really helps you guys understand what debugging would look like in the real world. Okay, and then we can just hit continue or step over. I'll hit continue because that will execute the code. As you can see, that returned the number 3. That means the code executed correctly. If there's anything that's wrong, that will fail. Let's try to do something like something that would cause it to fail. Return XY. I think that will fail. So if we run that, okay, that did not, oh, okay, I did not save, okay. So another thing, when you're writing code, always remember to save your code. That happens all the time. Okay, so in this case, you see in the output, you're gonna get an error return. And that's where compilers come into play. So if you remember correctly in the beginning, I was talking about how your compilers also throw out compilation errors. So this is an example of a compilation error. When you try to run the code, your compiler is not gonna understand the syntax, and it's gonna throw it out. And yeah. Okay, that was the workshop. That's the basic demo I wanted to show you guys. I hope that really helped you guys kind of understand what an IDE is used for and how you can do more things with it. And yeah, thanks for coming. So this is going to conclude the workshop. If you have any questions, message us on Discord. There's TAs everywhere. We'll try to get back to you as soon as possible. And yeah, happy hacking, guys. Thank you.